Okay, then welcome back, and as you can tell by the title, today is going to be all about CNC. Okay, and more specifically CNC milling machines. I use two different ones to make PCBs on, and I thought I'll take you through how to use a CNC mill, so you can use it yourselves if you've got one of these. If not, then you can get an idea of how to use one and the benefits of them. Okay, so we'll go through the benefits. First of all, a CNC over etching. Okay, it's a win-win situation all the way around. Okay, the only time when you really need to use etching is if you're going to be doing mass production, okay, of circuit boards. Reason why I think milling is a lot better is because there's no chemical processing involved at all. Okay, and that's a huge bonus. There's no need to mess about with health and safety crap for chemical storage or usage or disposal. You don't have to wear particularly funky protective clothing or any gloves, goggles or anything like that. So all that stuff goes out straight away out the window. There's no need to do any processing of etching. Okay, you don't have to worry about over etching or under etching, things like that. You don't have to worry about your sensitized boards, developing them, printing out acetates, making sure that you got them around the right way and everything. Because basically CNC is you're going from a PCB that's generated on a computer into a format, into a language, something like a Gerber as usual, to go onto a CNC milling machine. So it's in computer format, going into computer format, and the computer is going to generate from that format, control the milling machine to produce it, your circuit board onto your board to get something out at the end of the day. There's as little possible paperwork or printing or developing or anything like that possible. Everything's done all in ones and zeros essentially. So it's a lot more accurate as well, because of that, you don't have to worry about your printouts being one-to-one. You don't have to worry about anything, because it's what you see is what you get. Okay, you go from paper to computer design to your final thing, all electronically. So that's why I think it's a lot better. Okay, and you get rid of all those nasty chemicals, knocking about, worrying about how old they are. Okay, whether or not they're up to scratch. And once they do wear out, okay, they're out of date, they're no longer doing what they're meant to be doing, but they're still very harmful to the environment. How to get rid of them? Well, you've got to waste a hell of a lot of money. Milling machine, all that you've got to do is worry about a bit of dust, which you can vacuum up, use a normal vacuum or one that comes with your mill, or just use a bit of IPA just to polish up your board at the end. As much as it is. Right then. So from the top, I'm going to be taking you through the a CNC mill, the Quick Circuit, or is it Quick Circuit 7000. Okay, it's made by T-Tech. Okay, Yanks as usual. Okay, but over in Europe we are making our own now, so you can go with LPKF if you want. Okay, that's one that we're doing is a Quick Circuit milling machine, and here's a picture of it up here. Okay. That's a Quick Circuit that we'll be running on. It's a flatbed milling machine. Some milling machines come with the controller all built in, the speed controllers built in and everything, okay, just vacuum separate. This one is everything separate, okay, and I like that because it means that when it comes to cleaning down, stripping back, things like that, maintaining the instrument, it's a hell of a lot easier. It's a hell of a lot better maintaining the equipment that way. It's a lot easier because it's in separate modules. Okay, so let's go through it. What are the component parts of our milling machine? Well, we've got our computer, obviously. We've got our milling machine, which is this over here. This bit does all the major work. You've already seen that. We've got our speed controller. Okay, that's used to control the speed of the milling head. Okay, you can either set that manually on the on this box, or it's all done, and usually it's all done through the computer. Okay, it's all remote controlled through that box straight to the milling head, and which does the cutting. Next one is the actual controller itself. Okay, this is what interfaces all the bits of kit. So your computer will interface to this, and this will go off to your speed controller, it will go off to the mill, it will go off to the vacuum, and so on. And finally, this is the vacuum. Okay, it comes with its own vacuum, this particular one, and they're the parts. Okay, so going down to the actual milling machine. Okay, we've got the it moves in X and Y. Okay, the big silver block, that's what you mount your board onto, and this is a picture of the milling head. Okay, this is the thing that does all the work, or primarily all the work, the stuff that does all the cutting. You set the material heights, cut depth, and everything else from that. Okay, so it's not an automated process. Okay, like I said, did I say? I can't remember now. Like I said, I've got two milling machines. I've got one from LPKF and I've got one from T-Tech, which is this one. The LPKF one is an automated process. It's a very, very hands-off approach. Okay, everything's done for you, and I'm not so keen on that. So if you do run into any problems, or if the machine does get into trouble, you're buggered. Okay, you have to make sure that everything is done precise on the automated one. So you have to make sure that all your tools are all set up, your board's all set up correctly, you've imported all your files correctly, you've all preset all your everything. You know, you have to make sure that you do everything absolutely to the book. On the semi-automated one, which is this one, which I particularly like. Okay, it's still automated, you still import your files, you can get it automatically generate its isolations or insulations, if you like, what they call them now, toolpaths, etc. It's like that, it generates itself, but it gives you the option to manually control your cut depths, speed at which it cuts, its traverse speeds and things like that. So if your bits do start to blunt or anything like that, you do have a bit of control over it, and you can get a little bit more life out of your tools, unlike the automated ones, which, you know, it works at a set speed or a set tool. If your tool blunts, then all you can do is throw it in the bin. You can't really get any more life out of it, because you can't slow it down, you can't speed it up, you can't change the cut, and, well, you know, it's a new tool that you got to buy. Whereas the semi-automated one, the manual one, you can get a lot more life out of your tools. Okay, and you don't have to work them so hard. So that's bits of our milling machine done. So, like I said, tooling, I guess, is the next thing. Okay, now CNCs use carbide tools. Okay, and they cut on a rotational cut. Okay, now we've got drill bits. We've got I've only got one left of this. Okay, let's get some more. We've got routers. Okay, you can also see them on the images flying up here as well, close-ups. End mills. Okay, you've got some end mills there, and we've got some universal mills. Okay, these ones have got two different names here. We call them universal mills, or you call them T cutters. Okay, the cheaper machines that you buy for a couple of hundred, just use these T cutters. I'm not a fan of these, but they do get you out of problems. I prefer to use end mills. Okay, and we'll run through the tools now. Okay, now drill bits do what they say on the tin. They're there to drill through your material, and they cut on the tip. Okay, so they cut on the tip down through the board. Okay, drill bits for making holes. Okay, with component holes for through hole, for vires, or for making your initial hole for using where's it gone? Your carbide router. Okay, carbide routers are used for either opening up holes which have already pre-drilled, So you say if you want a, I don't know, 1.2mm hole and you've only got a 1mm hole, you can use a carbide router to actually open up. You can pre-drill to 1mm and you can open it up with using a carbide router because it cuts on the edge. Okay, carbide routers cut on the edge, and it cuts on the edge and it can buzz out the hole to 1.2mm, okay? So it can open up a hole to the size that you want, but also they're used for either cutting the outline of your board, so it's chopping your board out from the material, like so, okay? Or doing internal cuts and things like pocketing, okay? So you can do pockets, or if you've got a particular, I don't know, maybe oval shaped holes for tags and things like that in your board, you can do an internal cut in your board with those, and they cut on the edge. Next one's up are your mills, okay? And you've got universal mills, which are T cutters, these ones here, and you've got end mills. Two different types, okay? Both for removing the copper on the surface of the board. They're surface cutters, okay? They don't go through the board, they just run on the surface, they cut on the tip. So let's go to the board. Right then, so we've got our drill bit, okay? Pointed end, okay? Mine's a little bit bent, but okay. This part up here, okay, is called the shank, okay? This is what you screw into your, or you attach to your milling, okay? And you do all the work with this part down here. On the automated ones, what you got here, okay, because it does automatic tool changing, okay, it's got a lead on the end of the shank. This is a shank lead, okay, and this is what jiggles into your chuck, okay. If it was straight, then if the chuck came down, it would knock the tool. That's called a lead. You don't really have to worry about that on the manual ones because you fit them yourselves, only on the automated ones. But it's, we've got our shank. Normally that's a 1/8 of an inch, okay, shank. Normally that's a set standard. And down here we've got our cutting tool, okay. Drill bit, cuts on the tip. Tip's pointed, designed to puncture the board. We've got our carbide router, okay. And normally, okay, it's a bit like, if you take a look at it, it looks like a, well, you've got two different types of routers. You've got a chipper and you've got a diamond cutter for doing PCBs. The diamond cut ones, okay, they're like diamond shaped teeth on the sides, okay, and it's used to grind and file away the edge of the board, and you get a really nice smooth edge. So smooth edges are really important. You'd use a diamond cutter. The other type, okay, it's similar to a drill bit. It's actually it cuts on the edge. So I don't know. Yeah, try and draw this. Okay, if the end of the mill's like that, it's like, it's a bit like an end mill sort of shape, and these are toothed. It's a bit like, it's like a bit like a fluted end mill. I'll tell you about what flutes are when I get to doing end mills. But it's a bit like a tooth on the edge of the board, and it's there to shave the board, okay, as you cuts the edge of the board rather than grinding, which is what the diamond cut one does. Actually a toothed cut, and it's called a chipper, and it's there to essentially chip away at the edge of the board. It gives you a rough cut, but the chippers are a lot cheaper than the diamond cut ones, shaped ones, but it doesn't give you such a clean edge. So it all depends on what type of edge that you're after. If you're doing something like, I don't know, microwave boards and things like that, where you're putting on end launches and stuff like that, or you're doing guides, you might be doing a wave guide or something like that, then a diamond cut one is a little bit better, because you might want to polish up the front of your board, so you want it as smooth as possible when you take it off the machine for polishing and so on. So that's those two. You've got two different types of things. So that's the drill, that's the router or router, depending on what part of the world you're from. The other ones are the end mills and the T8. So end mills first. That'll be easier to explain. Again, we've got the shank. And it comes. Terrible at drawing. I've got to get better at drawing. Okay, and it comes down to something like that sort of shape. This okay, and what the end mill does is it on the bottom of your end mill, you can see it a little bit clearer up on the screen here. Okay, it's a bit like an S shape like that. Okay, on the bottom of the mill, and it's designed to cut on the actual face of the mill, on the front of the mill, and very, very slightly on the edge. So it cuts very slightly on the edge, but it's mainly there to cut across the mill. As this rotates, okay, it's a bit like you've got a blade at the bottom and a blade at the opposite side, and it cuts into the board, okay? So it scrubs the board. This one is removed for removing copper off the top of your board. And the width, okay, is the diameter of your circle. Down here, the diameter of your cutter. That's your cut width. So when you're cutting your board, okay, if that's your board and you want to cut, okay, when you cut this board, it'll cut a line, something like that. So this will be your around here. If you imagine the white is the remaining copper, the black is where the tool's going, so it isolates around your track, okay, to a specific width, okay. And that's what the end mills are for. They're for doing accurate cutting. So if this track was 1mm, okay, you go around it 1mm thick. You go around it with a, I don't know, a 1mm end mill, and you'll get a cut. It'll cut the material around the outside edge to a width of 1mm, and it will leave this as 1mm in here, track, okay. It's pretty simple, okay. You'll understand that a little bit more when we come to actually making a board, okay, so you can actually see it in motion. The other tool is the, well, no, actually we'll go back to the end mill. We'll go through that again. We'll go from the side, okay. So we've got our end mill, okay. If we take a look at our PCB from the side, okay, side on, you'll get an idea. So if that's our material, okay, that's our substrate. This is our copper on top, okay. That's our copper. When the end mill comes down onto the top of the copper, the width of the end mill is going to cut into the copper, same width as the tool, so you end up with a cut in the copper, okay. Now if we do this in 3 dimensions, there we go, okay, something like that, okay, we end up with, say, a circular cut, okay, going down into the board, because our tool's gone into the board. As our mill moves, okay, so it's going to move back, okay, down the copper. It's going to do a trench that looks something like that, okay, in a copper board, okay. So it scrubs out the copper on the top, the same width as the tool. If you want to make a track, you go all the way around, okay. So if we want to make a track in the board, we go all the way around. Try and do this, okay, there we go, back again. Right, so what on earth am I looking at here? I really don't know. Really difficult to do this on whiteboard. So track would look something like that. So our milling machine, milling heads come down with a tool, it's cutting to the copper here, okay, in that area. It's travelled down, travel back to here, okay, back to the edge of the board, Okay, it's cleared out all the copper in this area, and it's left us with copper in the centre just there. Okay, and it's copper all around here, except for there. Okay, it's a little bit more clearer, but I wish I could draw a little bit better, but I can't. Okay, that's what an end mill does. Okay, it surface clears the copper off the board. But I said it does that to a precise width. Okay, so that's gone around that track. So if this track was 1 millimetre thick, that's running down the centre here, it remains 1 millimetre thick, because our tool is, I don't know, it could be any size tool. It could be 0.2 millimetre tool, it could be 0.1. It will go to the edge of this copper track and it will remove around the outside edge whatever width this tool is. Okay, so it isolates out that track. Now then, our next tool is the universal cutter, and you get these on the cheaper machines and more expensive machines. Okay, the universal cutter, or the T tool, it's that shape is actually a triangular cutter. Okay, it's an angled cutter, hence the name T. Okay, and it's triangular, and it's also called a universal cutter because depending on how deep this tool goes, we zoom into this, okay, into that. Okay, this is a T cutter here. Okay, the deeper we go, okay, if we've got our copper board, if it's on the very tip, okay, if this is the copper board sheet here, okay, it's working on the very tip, it's going to cut a very narrow channel, okay, into the copper if we work on the very, very tip. So if we bring this tool down, what will happen is, that's our copper and our substrate again, okay, as we bring this T-shaped cutter down into the board, it'll cut a triangular shape into the board. Okay, so just like before, okay, it'll cut a triangular groove into the board. The problem here is, the further you go down into the board, okay, in order to hit the substrate down here to isolate your board, okay, you need to drop the tool. So the problem is, okay, further you go down, okay, in order to go through the substrate, further up the tool you need to go. Okay, the further up the tool you go, the wider it gets. Okay, so you can do different widths of cut with the universal cutter, but you're stuck with an actual ballpark round rough figure of how wide the track is, the cut is. So if you're cutting, you want to cut at 0.2 millimeters, okay, you can set the height so that you get a cut of, say, 0.2 millimeters. So the top is here, okay, 0.2. Trouble is, it may not have gone through the board, okay, or you may have to go through the board a little bit deeper in order to maintain the clearance. So you've got to go deeper. Well, because you had to go deeper, your tool is increasing because it's triangular. Then you might start cutting at 0.4 millimeters and 0.2 millimeters. So your width increases. And you think to yourself, well, that's not too bad. You just set the depth, and well, off you go. It'll cut all my. That's that particular size. It goes board. Who cares? Well, unfortunately, the PCB material isn't flat. Okay, if we take a look at our material, okay, the surface of our material isn't a straight line. It's actually slightly rippled. Okay, if we zoom into it, okay, it's not a perfectly flat material. It's impossible to get any material perfectly flat. So the problem is when you set the height, you may set the height up here to the thicker material, okay, and it might cut to 0.2 here. When it gets to here, it might not, it'll cut, but it'll cut slightly deeper because it's shallower, so you get different cut widths across the board, so you don't get an even cut like an end mill. It's a square end, okay, and it comes down and it cuts a square channel. T cutter cuts a triangular channel or a V-shaped channel, okay, and depending on whether the board's wavy or not, or how smooth it is, you get different cut widths, and it can cause a problem, okay, which is why I'm not so keen on these end mills, okay. Now, if the board is particularly wavy and rippled, you can use an end mill. It'll either cut through the board or it won't, okay, or it won't go fully through the board. All that you have to do is pass this over the board again, adjust your cut height so it cuts slightly deeper. It'll go around the board again. You won't make your isolations any wider, and yeah, not a problem. You don't lose any copper you want to keep, unlike the universal cutters. You might start cutting slightly deeper or slightly shallower, doesn't matter. Okay, cuts too deep, you may start trimming off 0.1 millimetre. You might think 0.1 millimetre isn't a lot, but when you're dealing with surface mount components and your pads are 0.2 millimetres and you start cut slightly deeper, an extra 0.1 millimetre, that 0.2 millimetre pad is now going to be 0.1 millimetre, so you're going to have less copper to solder to, so it can be a problem. So I always say go for the end mills wherever possible, and you do the least amount of work with the universal cutters. So that's milling tools done, okay. Like I say, as we go through and we start to actually do the board, you start to see a little bit more how to use them, and you see all the pros and cons. Anyway, that's tools. Next up, what shall we do now? Well, every yeah, that's about it really. So let's do the health and safety stuff first, okay, on milling machines, okay. First of all, you've got to realise that you're going to be milling at, your rotational speed is going to be quite high, okay. You can go up to, on this machine, to 60,000 RPM. So you're going to have circular cutters, okay, you're going to have a lot of mechanical movement in the head. You've got your XY bed, your milling bed, it's on an XY control, so your head's going to be moving backwards and forwards, left and right, making your board. So be very, very careful when the machine is in operation. Keep your hands away from the machine, okay. Computer drives the machine, your hands don't. Okay, so keep your hands away. When you're doing any test cutting, you have to get up close, so whatever you do, if you've got long hair, make sure it's tied back and out of the way, because you don't want your hair to come loose and get caught up in the mill when it's on the go and rip out your hair, because that will happen, okay. And also, clothing. If you've got baggy clothes, like this, so I've got a jumper, okay, it's quite baggy, you can see it there, okay. If you work with a mill, okay, make sure that your baggy sleeves are all pulled up and out of the way, okay. And if you do have any clothing on, try and make it short sleeve. If not, pull it back out of the way, okay. So you've got as little things dangling around the machinery as possible. Same go with necklaces. You might lean over the machine to take a look at the cut to make sure that it's cutting nicely, and you don't want any necklaces or jewellery dangling into the machine and getting caught up and end up choking yourself to death, okay, because these machines can be quite dangerous. And can't say enough, keep these away from the milling head. It's very tempting to brush away debris on the surface of your board, okay, when it's in operation, okay. The vacuum's there to suck away the debris, doesn't always get rid of everything, but try and keep your fingers away and avoid brushing it away. If you're going to want to brush away anything, use a brush, okay, don't use your fingers. I've used them in the past, and I have almost lost the tip of my finger once or twice because I brushed stuff away. Okay, I haven't bothered moving my hand away. I just looked over to the screen for a second, and the mill's actually come forward and it's hit the front of my fingertips. Okay, and I've had blood up the machine, so be careful. Okay, keep your fingers away. And that's all we'll say about this. Okay, so a basic introduction, a little bit about tooling, a little bit about the machine, a little bit about health and safety, a little bit of moaning, and part 2 we'll start looking at Gerber files, importing Gerbers into the software that the machine uses. Okay, so we're looking at Gerbers. Be talking about extended Gerber, which can be a tricky one to work with. Possibly editing a Gerber file. Okay, so I'll take you through a Gerber, what it actually looks like. Okay, when you export your design, how to import that into the software. So we're going to be using ISO Pro for this. Okay, there's an image of it up there, and be taking you through choosing the isolations, things like that. So doing isolation, rubbing, importing drill files, setting drill sizes if they're the wrong size, checking over the board, and so on. And we'll go on from there. So next one, we'll start getting down and dirty with actually importing a file and possibly having to edit it and working with it. Okay, and then in part 3 we'll do the actual milling process. So we'll get down and dirty on the mill, setting speeds, etc. And go on from there. So goodbye for now.